The topic is finding limits of functions of two variables. So let's do first example. Show that limit of 3x squared plus sine square of y over 5y over x squared plus 5y squared does not exist. So if we look at the definition, to show that a limit does not exist, you need to show that a limit of f of xy as xy approach AB along a path C1 is not equal to the limit along another path C2. Alright, so what do we do? Which path we pick? I mean, I notice here when I see sine, I know it's something usually kind of a little bit harder than polynomial, but I notice if I plug a 0 for x and a 0 for x here, then I'm going to end up with just the right side of this line, which means sine square over y square. And then I'm thinking maybe I can use L'Hopital's rule. So let's do limit of, let's call this f of xy. So limit of that function f of xy as xy approach 0, 0, and I'm gonna say along y-axis, which means along the line x equals 0. This will be equal limit, right, of f of 0y as y approach 0, which means whatever I see x I plug as 0, this will be limit 3 times 0 square plus sine squared of y over 0 squared plus 5y squared as y approach 0, which is equal limit sine square of y over 5y squared as y approach 0. Now this is very easy. I can take 1 over 5 outside, and this will be limit sine square of y over y is the same thing as sine of y over y squared as y will approach 0, right? Sine times sine is sine squared, y times y is y squared. But I know that the inside is just 1, so this is going to be equal 1 over 5 times 1, which is 1 over 5. Y, let me use it here. Limit of sine of y over y as y approach 0. You can L'Hopital's rule will be limit. Derivative of sine is cosine y, and derivative of y is 1 as y approach 0, which is equal cosine of 0, which is 1. Alright, now, I mean, what would be another easy path? I want on y, if I plug y equals 0, I notice that I'm going to just look at the left side. So what I mean with that, let me write it down here. Limit of f of xy as xy approach 0, 0, and I'm going to choose along x-axis, which means along the line y equals 0. This will be equal limit of f of x, the y becomes 0. Now this is a function of x, so all I need to know is y approach 0, which is equal limit. Now I'm gonna plug a 0 for y's, so this will be 3x squared plus sine square of 0 over x squared plus 5 times 0 squares as, whoops, it's a function of x, as x approach 0, right? Now this is going to be equal limit, sine of 0 is 0, 0 plus 3x squared is 3x squared, x squared plus 0 is x squared, as x approach 0, simplify the x squared, and then you'll get 3. Right, so we got 3 and we got 1 over 5, these are not equal, therefore limit of f of xy as xy approach 0, 0 does not exist. Alright, let's do a next example. Next example involved absolute value. So remember, absolute value of x, let me write this down, definition maybe. Absolute value of xy is equal xy if xy is positive, which means x positive and y positive, or x negative and y negative. Now also definition says absolute value of xy is equal opposite of xy if xy is a negative number, which means, so if xy is less than 0, means x positive and y negative, or x negative and y positive. So if we choose two paths, any two paths, actually, let me draw y-axis and the x-axis. So if I pick, for example, a path that comes from x positive and y positive, meaning any path that's going that direction, could be that one, it could be that one, doesn't matter. And then another one where, for example, x positive and y negative. So here's x positive and y negative. So I've picked a path that's approaching the point 0, 0. See what's going to happen. So limit of f of xy, again I'm going to call this f of xy, as xy approach 0, 0 along any curve, pick a curve, actually along a curve where x positive and y positive, this will be equal limit of xy, absolute value of xy becomes xy, as xy approach 0, 0. Now I can simplify these two and I'll get a 1. Now limit of f of xy as xy approach 0, 0 along a curve or any curve where one of the variables positive and the other one is negative. I'll just pick x positive and y negative. Now what happened? This is going to be equal limit of xy, and now absolute value of xy will be equal minus xy, because one of them is x is negative and y is, x is positive and y is negative. Xy approach 0, 0. Now I can simplify these and I'm going to get a negative 1. So these limits are not equal, therefore I can say limit of f of xy as xy approach 0, 0 does not exist. And that's it for this example.